Hello, this is Kurt McNamara from the Natural Systems Working Group of NSWG, the International Council of System Engineers. Today we're talking about transportation as a system of systems. And by that we mean there are so many independently interacting parts. They're designed separately, they operate independently, and yet they interact. The best way to understand how this whole thing works together is what's called a system of systems view. That means multiple viewpoints, multiple stakeholders. It could include life cycle, certainly includes operation. It will include the information view, the physical, energetic view. It would have something about the construction and life cycle of the systems and the humans and their interaction and the functions. Mostly this all works well, but occasionally we have what's called bad emergence, things happening we don't like. And of course, we want to improve things. We want to increase the sustainability and improve the efficiency. So this technique of taking multiple views, and they're not just individual points of view, there are different ways of looking at it. So we might have flow diagrams or queuing diagrams or life cycles or how people interact with it. And then we start to look at how those things come together, and that provides us with the ability to kind of look ahead and see opportunities as well as challenges, because we want to find places to innovate, and innovation at the systems level is much more powerful than trying to just change a part and thereby change a system. This means a more networked view, means many people taking a look at it, people you might not expect, right? People you might not normally have in this process working together. There is a process called gigamapping where we just try and make enormous maps of all the interconnections, but then we need to move to these distinct points of view and see how they interact, overlay, and intersect. Once we do that, now we have a chance to move away from a hierarchical view, which is more typical of our design systems, into one that's a more networked view, which is more characteristic of nature, where nature often has many parts interacting independently. We know this will wind up, because looking at nature, we know that nature works with information and structure, not as much with energy and materials. And so one of the examples is the slime mold, which has this amazing life cycle, has already been used to map out transportation networks and creates models very similar to what we have done, which means they can be used for new opportunities. Vascular systems, systems of flow within the human body and other places. Constructal theory gives us many insights into how to construct things and how the smallest openings should be sized to the individual agents. Just the processes of nature like diffusion and the way that things transfer as opposed to being forced by energy is intriguing. The way that the social insects interact to create their dwellings and to make decisions about where the next hive should be is astonishing. Of course, the ants as well do all kinds of things to maintain the colony. And once again, it's simple signaling between the individual ants that produces this complex behavior. They work in parallel to do really complicated systems and challenges like taking apart a big food source and getting it back efficiently into the nest. So, and another, birds and migration, just flocking together, we'll see in a minute, and flying in a V gives advantage to the birds as well as it gives different points of view to navigation, and they have so many navigation systems. Flocking together, once again, simple rules and a complex behavior that's extremely useful, and we can gain from looking at each of these things. So there's many examples, as nature has a great variety, and once again, we want to look at the systems view, right, and come up with systems level improvements, and that will allow us to get more towards the good emergence and look at new opportunities that are more powerful because they're the systems level. So this is us. Just Google NSWG and NSWG, you'll find us. Here's the references. We'll make a copy of this available, and the primer that we have just releasing for review is available at the Biocene. So we hope to talk to you soon.